Day 18 example. The first example is, what is the pH? So there's your question. What is the pH of a solution containing 0.1 molar acetic acid and 0.1 molar sodium acetate? All right, and it gives you Ka for acetic acid. Wonderful. We have both an acid and its conjugate base in solution. So let's write out the equilibrium expression for acetic acid. So acetic acid plus water is in equilibrium with hydronium and acetate. All right, now what about the sodium? Right, we know that sodium acetate is a strong electrolyte. And since sodium acetate is a strong electrolyte, we don't need to worry about anything happening with sodium. We know we have 0.10 molar acetate, and we know we have 0.10 molar acetic acid. And we know that from the problem. Now, we are going to assume our concentrations of acetic acid and sodium acetate remain the same, right? Because we already talked about this in a previous lecture, that the acid doesn't really ionize that much, and the base doesn't really hydrolyze that much. So we're just going to ignore both of those and say that it's a wash, and just say we both have 0.1 molar acetic acid and sodium acetate, or acetate in this case. Well, this would be a buffer, right? So a buffer. Now in the buffer we can use the Henderson-Hasselbalch equation. pH equals pKa plus the log of the conjugate acid, the conjugate base, over the acid. So the conjugate base would be acetate over the acid. All right, so pH, which is what we're looking for, pKa, negative log of 1.8 times 10 to the negative 5, plus the log of my base, which is 0.10 molar, over my acid, 0.10 molar. Same concentration. Well, the log of 0.1 over 0.1 is the log of 1, and the log of 1, as you guys know, is 0. How convenient. So in this case, the pH equals the pKa, all right, which is negative log of Ka. pH happens to be 4.74.